Hello Year 12 and welcome to the first video for our second last topic, which is motion. Now, in this topic we're going to look at things like velocity, displacement and acceleration. We're also going to talk about some other quantities, speed and distance travelled. Now we need to explain some of these things. Displacement, we're talking about movement in a single dimension. Right, so up and down, forwards and backwards, positive and negative. Now, we will talk about 0 being our origin. Displacement could be forward of that or behind that. It could be positive or negative. If, however, we're talking about distance travelled, right? When I talk about distance, I'm not interested whether it's forwards or backwards. Just sort of how far it is, just the magnitude of that change in displacement. The magnitude of that, not the direction. So we call that a scalar quantity, right? If it has no direction, if it's just magnitude, it's scalar. If direction is included, we call that a vector quantity. Don't confuse that too much with the vectors that you might have seen in, say, physics. That we're using this as an adjective in a broader term, that my displacement, my velocity and acceleration are all vector quantities. The good direction. Now, we're going to be talking about displacement with respect to time. Okay, so displacement, x, will be described in a function in terms of t. We could say x equals the f of t. X is sort of the opposite way, in a different place to what it is when we're not talking about x and y's. X is a function of t. Now, because I have some function, and I could graph it, if I choose 2 points along that curve and draw a straight line between them, that will be a chord. Chord being a straight line that joins 2 points on the curve. The gradient or slope of that chord will describe the average velocity. Okay, the average velocity between those 2 points in time. So, average velocity, change in displacement on change in time, or x2 minus x1 on t2 minus t1. Let's see how this works. In our first example here, we've got a ball thrown straight up in the air, and we've got some function here that describes its displacement in terms of t. If I were to expand this out, I would see that I have a quadratic equation, and it would be concave down. Right, as you would expect, I suppose. When you throw a ball into the air, it has a maximum. We have limits on the domain and consequently the range, so we're only interested in the domain from 0 to 8 for the time. And that means that x is going to be to somewhere between 0 and 80. Now my first question here, what's the maximum displacement of the ball? Well, my range suggests that my maximum displacement is 80, but can we work this out? I have a quadratic here. If I were to if I find the roots of this, let x equal 0, of course that's not the maximum displacement, that's going to be the minimum displacement, but we're getting there if we are to find the vertex of this. So I will have roots at 0 and at 8. Halfway between that will be t equals 4. So the axis of symmetry of this curve here will be t equals 4. Substitute that in and I get 20 times 4, which is 80. Okay, so my maximum displacement is 80 meters. Now, moving along, average velocity between t equals 2 and t equals 4. Well, if t equals 2, let t equal 2, then x equals, what have we got here? There's my function. T equals 2, so I've got 10 times 6, x equals 60. So after 2 seconds, my displacement is 60 meters. T equals 4. Then I have 20 times, we've already looked at this, 20 times 4, which is 80. Therefore, my average velocity, I don't have an abbreviation for average velocity, I'm just going to have to write it out, equals 80 minus 60 on 4 minus 2 is 20 over 2 equals, is 20 over 2 equals 10 meters per second, right? The difference in the x's, so x2 minus x1 over t2 minus t1. Now between t equals 4 and t equals 6, I already know what t equals 4 is. Let's just do this. Let t equal 6, in which case x will be equal to 30 times 2 is 60 again, right? Not very surprising because it is, of course, symmetrical. Therefore, my average velocity well, it's not going to be 10 because this is my t2, this is my t1, so it's negative 20 over 2 is negative 10 meters per second. The average speed over those times is the same. The average velocity, on the other hand, is opposite in direction. In the first instance, it's going up, then it's reached its maximum, now it's coming back down again. Now, between t equals 2 and t equals 6, my change in displacement is equal to 0, so it's 0 over 4 is 0 meters per second. Now, that's a little bit confusing, perhaps, that we know that my ball has moved quite a lot between t equals 2 and t equals 6. It has, in fact, travelled 20 metres up and another 20 metres down. It's moved 40 metres over the period of time, but its velocity, its average velocity between those 2 points in time is 0 because it's back to where it was, right? Its displacement is the same at those 2 points in time. Rightio. So that's the first bit that we need to look at. Moving along now to distance travelled. We've hinted at this already, that distance travelled is different to a change in displacement. Okay, the distance travelled, I want to include the positive parts and the negative parts, the absolute value of each of those, in a similar kind of way, if you like, to finding areas when we integrate, that we need to treat the parts above the axis and below the axis separately. Okay, because area, like distance travelled, is a scalar quantity. We're only interested in the magnitude, right? We don't want the positive and negative parts to cancel out. So my average speed is the distance travelled over the time taken. The distance travelled can be a little bit fiddly to work out. Generally, what you want is a graph so that you can see which parts are positive and which parts are negative. So the average speed here, now we worked out that my distance travelled, we already spoke about this, my average speed, my distance travelled is this time 40 metres over 4 seconds equals 10 metres per second because it's directionless. So we have moved 40 metres, so that's an average of 10 metres of movement every second between those points in time. Rightio, that's it for the first of these videos. We're going to move on. There's only 2 more to come after this. Hope you enjoy it, and I'll see you in class.